Yes, sir.
Okay, so good morning. Uh, our today's lecture is based on these are the based on the design matrix, which is a another important concept of software engineering. As you know that design is the blueprint of any software. Okay, so the basic purpose of matrices is to provide quantitative data to the management process, which is useful for effective monitoring and control. So there are mainly two functions of management. First is monitoring, and second is control. So design matrices uh, uh, provides provide help to for in effective monitoring and control. Okay, so these are the contents of our today's lecture. We will discuss about design matrices. There are two types of design matrices. First is network matrix, and second is information flow matrices. Secondly, we will discuss about the verification of the design. When you make a design, how to verify it and why verification is needed. Then third point, we will discuss about design review and inspection. Why a review of design is needed, why inspection is needed when you have already designed something, designed your software. Then we will discuss about object-oriented design, why object-oriented design is needed, okay, and what it is actually. The In the fifth point, we will discuss about the object-oriented analysis and object-oriented design. It is a technology, how to this is only for introduction, just for introduction about OAD. Okay, not in detail, but our focus in this class is object oriented designing. Okay, we will later on we will discuss about object oriented analysis. Then the uh, uh, sixth objective of this presentation, this lecture, is to elaborate, to discuss about the object-oriented technique, that is OMT, and last objective of this lecture is to discuss about the structure design methodology, that is SDM. Okay, so this is these are the contents. Those we will discuss about in this class. Let us start with design matrices. So as I said that the basic purpose of matrix is to provide quantitative data to the management process, which is useful for effective monitoring and control. Okay, so for estimation of the size, the total number of modules is an important criteria. When you are going to estimate the size of your project, you are saying that your project is very big project, or you are saying that your project is a small project. uh, do you remember the Kokomo model, Mariam? Do you remember the
Yes, sir.
Kokomo model? Okay, so uh, through the Kokomo model we have learned about the how to estimate the size. So for estimating the size, the total number of modules we have to decide, because it is an important criteria. Decomposition, we should decompose. In the previous class we have discussed about the decomposition and why decomposition is needed, uh, because we have to make simple programs, we have to make a complex problem, we have to solve the complex problem in a easy way. So decomposition is needed. You all you know that decomposition means breaking down the problem, okay, in number of modules. So this is the basic phenomena of basic thing of basic concept of your effective or quality design. So for estimating the size, the total number of modules is, you can say, it is an important criteria, and this data can be easily obtained from the design, because decomposition is the method of designing by using an average size of a module. from matrices, the final size in LOC. LOC means line of code can be estimated. Okay, so if you are having uh, some matrices, you are having some uh, calculations, you are having some formulas, you can easily estimate the size of a module. Okay, average size of a module, not exact, but average size of module. Okay, so the first thing, there are two types of design matrices. Basically, there are so many matrices, but we are discussing about two matrices which are very important. First is network matrices. So network matrices for design focuses on the structure chart and define complexity of the structure. Okay, so first matrix is related to the uh, uh, first matrix, that is network matrix, is for design focuses on the structure chart. Structure chart is a tool, designing tool. Okay, so it focuses on the structure chart and define complexity of the structure. If means, you can say that uh, what is complexity? You can say that complexity means what? Number of nodes in the structure chart minus actually needed is the impurity, is the complexity. Okay, number of nodes in the structure chart minus actually needed nodes. Okay, so the graph impurity means what? Graph impurity shows the complexness which is depicted. You can depict it in the structure chart easily through a formula. What is that formula? Graph impurity is equal to number of nodes in the structure chart minus actually nodes needed. Okay, so in a pure tree, the graph impurity should be zero. If there is no impurity in the graph, you can make a very quality design. Okay, so this is one thing. Second thing is, the second design matrix is information flow matrix. Okay, so the inter module complexity of a module depends on the total information flowing in the module, that is called inflow, and the total information flowing out of the module, that is outflow. So there are, in a module there are two things important. First is inflow and second is outflow. So yeah, when you are talking about interconnectivity or inter module complexity. Okay, so the total inflow and the total outflow, you should estimate, uh, uh, correctly estimate the thing. Okay, the intra-module complexity depends upon the inflow and outflow of information between two or more modules. So there are two types of complexity. First is inter-module complexity, which is a complexity introduced within the module. What is inflow and what is the outflow within the module? Okay, second is intra-module complexity, which is depends on the inflow and outflow of the information between two or more modules. Okay, do you understand the thing?
Yes, sir.
Okay, so you can make a formula. What is that formula? Module design complexity is equal to overall size of the project or product, overall size of the project, multiplied by intramodule complexity, multiplied by intermodule complexity. Okay, so uh, this the multiplication between intramodule complexity and intermodule complexity provides you the overall module design complexity. Okay, so this is the basic formula. I am repeating again. What is the basic formula? You can design a formula with your own. Module design complexity is equal to overall size of the product multiplied by intramodule complexity multiplied by intermodule complexity. Okay, so uh, when you multiply the intermodule complexity and intramodule complexity, you can easily produce the you can easily estimate the uh, module design complexity. Okay, now the term there is a one term. What is that term? Important term. What is that term? Fine tuning of the system. How to tune your system, how to make your system considerable, how to make your software more effective, how to prepare your how to design your system more in an effective manner. So there is a term, fine tuning of the system. Okay, so fine tuning of the system considers the structure of the fan in and fan out of module. Fan in of a module is the number of arrows coming in the module, indicating the number of super modules of a module. Okay, in means what? There are number of arrows, means there are number of connectivity in to the module. Okay, so these are the when arrowhead in the when there are number of arrowheads to the module is called from the super module is called fan in. Fan in. Okay, fan out means what? Fan out of a module is the number of arrows going out of that module, indicating the number of subordinates of the module. So there are two important things, fan in and fan out. You have to balance the fan in and fan out when you are designing your product. Okay, when you are designing your product, you should uh, make a balance between fan in and fan out. Fan in means fan in of a number of a module is the number of arrows coming in the module, indicating the number of super modules of a module. And fan out of a module is the number of arrows out going out of the module, indicating the number of subordinates of the module. Okay, do you understand?
So, please come again.
Yes. We are talking about the fine tuning of the system. Okay, we are uh, we are talking about the fine tuning of the system. So fine tuning of system is related to the fan in and fan out of modules. Okay, what is fan in? Fan in means a module has a number of arrows coming in the module. When you are drawing something, when you are drawing number of modules, and you are showing the connectivity between modules through some arrows. So the how many arrows coming in to the module is the fan in value. Okay, number of arrows coming in the module, indicating the number of super modules of a module. Okay, so values from super modules come into the uh, subordinate module, which is called through some arrows. You can show arrows in your designing. When you are designing your product, your software, you are making structure chart or DFDs or decision tree or decision table. Then you are depicting you are mentioning some arrows, na? So these arrows, how many arrows approaching to a module is called fan in. Okay, and how many number of modules sorry how many number of arrows going out of that module is called fan out. Okay, okay,
Yes, sir.
okay. So a very high fan out is not considerable. It means that the module has to control and subordinate too many modules and maybe too complex in nature. Okay, so if one module having number of arrows, if a module having number of arrows like this, I am drawing one picture. Can you see it?
Yes, sir.
Yes. And this is the arrow 1, this is the arrow 2, and this is the arrow 3, and so on. And these are the subordinate modules. So what we are doing, this is the super module, and these are the subordinate modules, and these are the fan in, these are the fan out. Okay, fan out in the case of this module, these are fan out. Okay, and what is fan in this case? Fan in means, okay, now this is fan in, and these are the fan outs. So there are two fan ins in this case, and in the case of module A, when we are saying that this is module A, then in the case of module A, there are two fan ins and three fan outs. Okay, these are the super modules of module A, and these are the subordinate modules of module A. Okay,
Yes, sir.
have you understand now?
Yes,
So
sir.
what is fan in? In this case, there are two fan ins and three fan out. Okay, so a very high fan out is not considerable. That means if there are two fan ins, then there should be one or two fan outs, not more than three, more than two, like three, four, five, because because the control, because it provides the complexity in the system. Okay, so fan out should not be increased above five or six. But in this case, if there are two fan ins, then it should be two fan outs. Otherwise, more than two fan outs means what? To increase the complexity. Okay, so in the case of in the when we are talking about fine tuning of the system, what is recommended? Fan out should not be increased about five or six. Okay, it is maximum. Five or six fan outs are the maximum. Okay, because there is if it is more than five or six, then we cannot coordinate, the module A will not coordinate or control with too many modules. Okay, so some problem arises if we are not considering, we are not yeah, considering this fine tuning mechanism of the designing. Okay, the next topic is verification of design. Verification of design. How to verify the design? Tell me. How to verify the design? There are two things. There are two things to verify the design. First is review, and second is inspection. Okay. Review means दोबारा से देखना. View again and again what you have designed. View it again and again to verify your design. Okay, so the output of the system design phase should be verified before proceeding with activities of the next phase. So, design review or inspections are the most common verification approaches. The system design review process is similar to the other reviews in that what will happen in that a group of people get together to discuss the design with the aim of revealing design errors or to reveal the undesirable properties. Okay, so in the design review process or design inspection process, we can have a group of people. They are sitting together and they have a discussion on the design and for revealing the errors presented in the design, error found in the design, and some undesirable properties they should eliminate it. Okay, so they should be eliminated from the designing. So the purpose of review is to eliminate the design errors or undesirable properties. Okay, the review group must include first a number of system design tree a team. Okay, we should review the number of system design team. We should review a number of detailed design team. We should review the author of the requirement document. Okay, we should review the independent software quality engineer. So a review group must include a member of the system design team. We should include in that review group a member of detailed design team because he knows each and everything related to the requirement, initial requirement or client's requirement. And the author of requirement document should be included in the review group. Why it is so? Because someone is needed to prepare the documentation. Okay, requirement documentation. So author of the requirement documentation should be included in the review group. Then the last one is independent software quality engineer, who is not responsible for anything, who is not bounded, who is not reporting to anyone. Okay, independent software quality engineer to provide unbiased view, to provide unbiased decision. Okay, or unbiased view. Okay, so an independent software quality engineer should be included in the review group. Author of the requirement document should be included in the review group. A member of the detailed design team is should be included in the review group, and a member of the system design team should be also included in the review group. Okay, then each member studies the design before the meeting and mark items in the checklist that the reviewer feels incorrect or need clarification. If some clarification, if you find out some errors or some fault in the system or some undesirable property in the system design, then he should write down that item in his book, in his copy, and when when the discussion held with the review group members, other members, he should present their view. Okay, his view. Members ask questions to the chief designer and he try to explain the situation. So the meeting ends with a list of action items which are acted by the design team later, and further reviews may be organized if needed. So this is the process of entire process of design review or inspection. I have elaborated what is the what why design review is needed, how to verify the design, and what are the what are the essential members of the review group, and how the review group uh, studied or resolved the problem. Okay, okay,
Yes, sir.
yes. Pratik is there.
Yes, sir.
Hmm. Okay. Then the next topic is object oriented design. Object oriented design. Okay. So abstraction in software generally takes two forms. What are that two forms? Tell me.
So what was the question?
Abstraction in software generally takes two forms. What are that two forms? Abstraction means what? And what are the two forms of abstraction? There are two types of abstractions available in first is functional abstraction and second is data abstraction. Okay. In object oriented design, the basic system component is a model that supports data abstraction. Okay, so the goal of design is to identify objects that the design contains and the relationship and interaction between objects so that the system implements the specifications. When you have some understanding about the system, when you are having a requirement analysis with you, and when you have a requirement analysis document with you, then what is important? Summarization of that data is important. Okay, so functional abstraction and data abstractions are generally two things, two forms of abstraction. But the object in the object oriented design, we are modules are supporting the uh, data abstraction. Okay, because data abstraction contains the goal of the design is to identify various objects and uh, uh, the relationship between the interaction between the objects and uh, so because so that we can design a good system. Okay, so uh, uh, mainly object oriented design is basically a related to the data abstraction. The next topic is object oriented analysis and object oriented design. It is again a very much important part. The main difference between object oriented analysis and design, object oriented design, is that object oriented analysis concerned with the problem representation, understanding, and specification of the problem. Okay, so object oriented analysis concerned with the problem representation, understanding, and specification of the problem, while object oriented design concerned with the solution representation. Okay, so there are two things. First is what is problem, how to represent the problem, how to understand the problem, how to specify the problem. Okay, that is the part of object oriented analysis. Okay, next is object oriented design, which is related to the solution representation, so which provides the representation about the solution of the problem. Okay, so there are two things. The goal of this design methodology, what is the goal of this design methodology, which is the goal of software engineering, is the goal of design methodology to create good quality software. Okay, okay, remember this thing, it is very important.
Yes, sir.
What is the aim of software engineering? The only one and only aim of software engineering is to produce the good quality software. Okay, make the software reusable. So what is the purpose of object oriented design and object oriented analysis? To make to create good quality software, to create reusable softwares. Okay, okay.
Yes, sir.
Yes, so there are two things. There are basically three things. First is real world problem, second is problem representation, and third is solution representation. So when we are talking about object oriented analysis, Object oriented analysis concerned with the real world problem and the problem representation. Okay, object oriented analysis, you can say that it is concerned with the real world problem and the problem representation, but the object oriented design is related to the problem representation and the solution representation. Okay, object oriented design concerned with the solution representation, so it is connected with the problem representation but not connected with the real world problem. Okay, but the software sorry object oriented analysis is connected with the real world problem and the problem representation, because in object oriented analysis you are connecting the your represent problem representation is related to the real world problem. Okay, so this is all about object oriented analysis and object oriented design, a short description given to you. In detail we will discuss later on. uh, Next topic is the object oriented techniques, that is OMT. OMT is a methodology. Okay, methodology, the three view of modeling system. It comes with three kind of models. First is object model, second is dynamic model, and third is functional model. Okay, now in we are talking about sixth point, that is object oriented technique, OMT. So what I said that it is a methodology that combines three views of modeling system, and it contains the three kinds of models. First is object model, second is dynamic model, and third is functional model. Okay, so what is object model? Object model that describes the static structure of object in a system. Object model describes the static structure of object in a system. Dynamic model describes the control structure of the system. Control structure of the system means what? Events and states. Okay, that control the control that represent the control structure of the system. Okay, and functional model. Functional model describes the computational structure of a system in terms of values and functions. Okay, so there are three kind of models in the object oriented technique, are the part of object oriented methodology. First is object model that describes the static structure of the objects in a system. Second is dynamic model that describes the control structure of the system, like events and states. And the last one is functional model that describes the computational structure of a system in terms of values and functions. Okay, now come to the next part, next thing. A typical software procedure incorporates all three aspects. When we are talking about OMT methodology, OMT uh, methodology of system design, a typical software procedure incorporates all these models: object model, dynamic model, and function model. It uses structures like object model, sequencing of operations in time, that is the part of dynamic model, and it transforms values, that is functional model. So we can say that OMT consists of what? OMT uses structures, OMT making sequencing of operations in time, and it transforms values. So OMT is a only methodology which is using three different kind of models. First is object model. I'm repeating again and again. First is object model, second is dynamic model, and third is functional model. Functional model provides the model transforms values. Dynamic model is used for sequencing of operations in time, and object model is uses structures. Okay, a word model has two dimensions now. there are two dimensions of model. First is a view of a system. It presents a view of a system. And second is a state of development. A view of system means what? It consists of object model, dynamic model, and functional model. And state of development means what? Implementation, requirement analysis. These are the state of development, stages of development. So a model consists of two things, generally two dimensions. First is stage of development, like uh, first stage in of the SDLC, system development lifecycle, or software development lifecycle, is requirement analysis. So stages of development means what? Like requirement analysis, designing of the system, and construction or implementation of the system, and maintenance and testing and database conversion. These all are stages of development. A model consists of two dimensions. First is stage of development, and second is view of a system. View of a system means what? As I earlier stated, that view of a system means what? Object model. It consists of object model. It consists of dynamic model. It consists of functional model. Okay, so a model, OMT model, consists of two dimensions, all three models, first thing, and all the stages of development is second thing. Okay, do you
Yes,
have
sir.
some queries? Please ask. Otherwise, do you have any query?
No, sir.
Okay. The next point is structure design methodology. Structure design methodology. Just a moment. The software is viewed as a transformation function. Through the software, you can transform the system. Through the development of software, you can convert one thing in another thing. So you can view a system, a software, as a transformation function that transform the given inputs into a desired output. And the central problem of designing software is considered to be properly designing of this transformation function. So there are two things. First is conversion from input to output in an effective manner, and second is the designing of the transformation function, properly designing of the transformation of function. So structured design methodology, SDM, is concerned with two things. First is to make the transformation function effectively, or designing a transformation function effectively, and second is conversion of the input into a desirable output. Okay, which is the aim of structured design methodology. Okay, during design, structure design methodology aims to control and influence the structure of the final system. The objective of SDM related to the hierarchical structure with functionally cohesive modules and as few connections between modules as possible, which is the solution to reduce the complexity in the system. When I taught you the coupling and cohesion, I elaborated this thing, that how to reduce the complexity in the system. You should uh, increase the level of cohesion instead of coupling, level of coupling. Okay, so and this is the basic criteria, this is the basic phenomena which structure design methodology adopted. Okay, so The objective of SDM related to the hierarchical structure with functionally cohesive modules as few connections between modules as possible. Factoring is the process of decomposing a module. Factoring means decomposition. Okay, decompose factoring is the process of decomposing a module so that the bulk of its work is done by its subordinates. There are four major steps in this strategy. You can um, see here in the slide. First is restate the problem as a DFD. Second is identify the inputs and output of output data elements. Third is first level factoring, and last one is factoring the input, output, and transformation branches. Sorry. Okay. So these are the major steps in the SDM structure design methodology. First is restate. Let us discuss all these four steps one by one. Uh, First is restate the problem as a DFD. There is some difference between the DFD drawn during analysis and during structure design. We are making, we are drawing DFDs, data flow diagrams, and during the uh, designing phase. So there are some difference between both DFDs drawing in the different phases. So in the analysis, a DFD is drawn as a model of the problem. The DFD during design represents how the data will flow in the system when it is built. In the modeling, major transformation in the system or software is decided. DFD is a very creative activity in which the designer visualize the eventual growth of the software, its process and data flows. So DFD is a very important tool. Data flow diagram is a very important tool. We can restate that problem as a DFD. We are restating the problem. We are restating the problem in the form of DFD during the analysis and during the design uh, uh, phase of the system. As the software does not yet exists, the designer have complete freedom in creating a DFD that will solve the problem straight in the SRS. So SRS, software requirement specification, is a very important document which is created in the early phase of the system, and it will resolve when we are uh, as the complete description about the proposed software is available in the SRS. So when we are being a analyst or being a designer, when we are uh, reading properly or mentioning properly all the requirements in a SRS, we can easily drawing the DFD. We can easily creating a DFD that will solve the problem stated as in the DFD, as in the SRS. Okay, so in the early stage it is because software is not exist now, so in the existence during the analysis and design phase, so designer have complete freedom in creating a DFD, and which as per the uh, uh, as per the client's requirement stated in the SRS. Okay, so restate the problem as a DFD is the first step of SDM. Second step, major step, is identifying the input and output data elements, which is a very important thing. You have to identify all the inputs and output data elements. Uh, I elaborated earlier also that what is fan in and what is fan out. So you have to identify all the fan in and fan outs in the for single module. Then the third step is first level factoring, means first level decomposition. Okay, first specify a main module whose purpose is to invoke subordination. Okay, the main module is a coordinate module, and for which input data items, and for each output data item an immediate subordinate module is specified. Okay, so uh, what it suggests this methodology suggests, SDM suggests that you should proceed to first level factoring. First, you specify a main module, which is the purpose of main module is to invoke the subordinates, and the main module is is a coordinate module, and it has for each input data items, or for each output data item, it coordinate with the subordinate modules. Okay, so what is the purpose of main module? The purpose of main module is to to coordinate with their subordinate modules. Each of the arrow connecting these inputs and output subordinate modules should be labeled, and finally, for each central transformation, a module subordinates to the main is specified. So, in nutshell, you can say that when we are going to design, when we are adopting the structured design methodology, uh, in the third step, we will make first level factoring. We will make a one single module, that is main module, and uh, which is the coordinating module, and which controls all the subordinate modules, functionality of all the subordinate modules. Likewise, you are when you are developing a software, you are creating a main menu, and there are main form, and all subordinate forms are connected to the main form. Okay, this is the general formula. Next, next fourth level and last level of this methodology is factoring and transformation branches. Factoring of Factoring the input, output, and transformation branches. This is the uh, another you can say another or last step of the uh, last major step of the structured design methodology, factoring the input, output, and transformation branches. Now, when I in the previous class I had discussed about the structured partitioning. Have you remember the structured partitioning? We have factoring the input modules, we have factoring the output modules and transformation modules, which are responsible for transformation, are segregated from the modules which are responsible for output, and modules which are related or responsible for input. Okay, so likewise, the factoring the input, output, and transformation branches is the last step of this methodology. The first level factoring, means decomposition, results in a very high level structure where each subordinate module has a lot of processing to do. The simplify To simplify these modules, they must be factored into subordinate modules that will distribute the work of a module. Each of the input, output, and transformation modules must be considered for functions. Okay, so this is the fourth and last step where you are decomposing modules. You are identifying and decomposing modules in three main categories of a system, of a software. You are categorize all modules who are responsible for input. You are categorizing all the modules who are responsible for output, and you should categorize all the modules responsible for transformation. Okay, so this is structure design methodology. This is all about structure design methodology. Okay. Today we have discussed about design matrices, about network matrices and information flow matrices. Secondly, we have discussed about verification of the design through a review and inspection mechanism. We had discussion about object-oriented design and OOAD. Then we had a discussion about the OMT and SDM, and we had elaborated all the four steps of uh, structure design methodology. Okay, this is all about from my side. Do you have any question? Then please ask.
I have one question.
Hmm.
You said SDM is considered with two things.
Your voice is not clear.
Hello, sir, can you hear me? Hello,
What you are saying? Yes,
hi.
SDM
I said
is.
yes, SDM is considered with two things. Sir, please can you mention those two things again? I didn't get you well.
SDM is.
Now, SDM, you said SDM is concerned with two things.
Yes, yes,
Yes, sir. Please, can you come again because I did not get the point
yes, yes.
well.
First thing is to convert the input into desirable output. Okay, first thing. First aim of the SDM is to convert input in the desirable output. Desirable output means user accepted uh, uh, output. Okay, first thing. And second is a properly designing of transformation function, because conversion of input into output is a transformation process. So uh, when you are designing a transformation process properly, then you are able to convert the input into the desired output only. Okay, otherwise it is not possible. So there are two aims of major aim of structure design methodology. First is to convert, to ensure the input into desirable output. Okay, convert the input into desirable output or user accepted output. Okay, this is the first aim. And second aim, design properly the transformation functions, because this type of conversion, this type of transformation from input to output is not possible without the proper designing of the system. Okay, so this is the aim of structure design methodology.
Okay, thank you.
Okay, do you have
Yes,
any
sir.
question?
No, sir.
Pratik,
Yes, sir.
any query?
No, sir.
I'm taking your attendance, and then we will you will leave the session. Okay, attendance is taken. Now you can leave the session. Thank you.